science teachers, and welcome to your Unit 1 preview on scientific thinking and inquiry. First of all, I just want to take a moment to introduce myself. My name is Megan Waters, and I am a 6th grade science teacher at Uplift Grand Preparatory School in Grand Prairie. First, I want to start out this lesson and this unit preview by setting the tone. This is a video of a classroom that displays inquiry-based learning at its best. So take a minute, watch the video, and this will set the tone for our inquiry-based unit.
This is still settling, but we found a lot of little organisms.
So cool. The real question we're trying to answer here is if it's safe to tube in the water, because I swim here every summer, and I just realized how dirty it was.
When we design a science lesson to be an inquiry-based lesson, we start everything around a central question that may last for one class period or a series of class periods. And then they work through some experiment and conversation, perhaps some reading, and they work together. And the answers are always just a little bit out of reach for the kids until they really reach a point where they have this sense of discovery. Each of you are going to be in a group where you're going to sample one parameter down at the creek. And then you're going to make an infographic about your parameters. So for example, maybe it will be temperature and turbidity. And then ultimately, what you're going to have to decide in your final prompt is going to be answering this question. Would you recommend to your friends coming from out of town that they go tubing in Boulder Creek?
If you just ask a question and then gave the answer, it would be the same as if you just read the textbook. So we don't like to do that. We like to ask the question and then give a lot of different experiences, both through media, through discussion, through research, so kids can start to answer that question themselves.
When we actually go down to the creek, it's an exciting day for the kids. We've talked up the idea that we're really in an outdoor classroom. Let's find a spot and let's sit down and start working on our physical survey of the area, everybody. So you'll work on your map first. Suddenly they're looking at it through a different lens. They're looking at it through a lens as a place where we're now going to be doing some sampling and some scientific thinking. If the water appears clear, is it clean? And then if it's not clean, what does that mean?
Mr. Schwartz gave us bugs that can live in healthy water and bugs that can live in unhealthy water. Yeah. We're gonna find which bugs are we find in here, and if they're all in like unhealthy water bugs, then we're gonna know that this is unhealthy water.
I think it's 5 ppm.
5 ppm, I think.
From what we found, there wasn't as much nitrate as we thought there would be.
We would still go swimming even though it seems pretty dirty, but we know that there's a lot of organisms in here, and that leads us to believe that it's actually pretty healthy.
And we spend the next class period sort of going through that data, and they put that into a poster, an infographic, where they can actually share with the class in a way that's relevant to the kids, something that's kind of flashy and interesting. What is the data that our group got? And then, what do we do with that data if we look at everyone's data together? So kids reach their conclusions a couple days after we do our sampling.
Because sometimes, like when you're just reading from a book, you don't really think about how this is actually real life and how it actually works.
We're working through some question together, and we're discovering things as we go. And kids always bring with them knowledge. And very often it turns out that the kids teach me a lot, and we're all sort of learning together.
So here we're looking at the first page of the unit plan, and there's a lot going on here, so we want to walk through a couple of steps about this unit plan and what to kind of focus in on. First of all, this is our inquiry-based scientific thinking unit, and the first thing I want to point your attention to is our global context, scientific and technical innovation. This is the piece that really shows our scholars their connection between science and how they interact with the world. So that takes us to our key concept, which is relationships. This is going to show our scholars how these relationships with science are going to expand throughout all of their different interactions and units throughout not only science, but also their interdisciplinary subjects as well. That takes us to our related concepts, which are evidence, interaction, and function, that references straight back to our relationships and then connects directly to our global context. This is a really important unit for scholars because I think out of all of our units, you will use this as a reference point as you move through all of your different types of units, no matter the topic. This also is probably the unit that will cross over most with all of the other disciplines. So it's important that we take note of that and we look at some different ways that we can utilize this piece. This is our statement of inquiry. Humans explore the relationships among interacting variables and use evidence to impact communities and find functional solutions using scientific and technological advances. That's a little wordy for sixth graders, so I've gone ahead and put a student language which is more student friendly, I believe, down here in red. But feel free to modify this however you want to in your classroom. You can use the original SOI or you can use the student language. So the student language is humans explore problems using variables and their outcomes to create solutions. We want our statement of inquiry to be something that expands through the whole lesson and kind of embodies all of those topics. Down here, you're going to see some factual, conceptual, and debatable questions about the statement of inquiry. So all of these questions here can directly fold underneath this student language piece. So what is factual? What is conceptual? What is debatable? I really love the debatable questions in this unit because as you see as we move through to our grasp, which is our assessment at the end, that these debatable questions are going to become really important in that piece. This page is a little overwhelming. These are all of the TEKS that you will be looking at for this unit. Like I said before, this unit, more than any other unit, is going to wrap into everything you teach this year. You should be able to take at least one or two or more of these TEKS and apply it when you're doing your labs throughout the year, and I'll be sure to put those in with our AMLs and AMUs so that way you can see what that crossover looks like. Something I do want to point out here is that the CA1 is not going to be over these particular TEKS in the sense that they won't be explicitly covered. With that being said, they are spiraled into the test. So what I'm saying with that is that the scholars are not going to be able to get to the meat of those questions on the CA1 if they do not have these skills first. So our goal is to wrap this into all of our units as we go. We've left this as a unit in sixth grade because sixth graders come in with a need for a foundation for these TEKS. So if we don't take some time to teach some of these concepts, it's going to be really hard moving forward for them. As they move into their other grade levels, we're kind of moving this unit out and incorporating it into other units. But as I said before, we're keeping this in sixth grade because we need them to really understand these TEKS as a foundation as they move forward, not only in sixth grade, but all the way through 12th grade. So this is a really important unit, even though you're not going to see these questions explicitly asked on the CA1. Okay, so this is our grasp, and this is the fun part. This is going to be our performance assessment that we're going to be using. This is written IB style, and if you taught with us last year, this is the same lab that we did with some modifications to it. So we're going to be designing a parachute for the Red Cross. You can find some more in-depth detail about this particular grasp when you go and you look at my investigation AMLs. But I did want to show you where to reference that when you get to that particular investigation AML, where it is in the unit when you get to that piece. So I wanted to go through what grasp means. This first part just kind of tells us the goal. What is the goal for this inquiry that we're going to be focused around? What is the student role? So what are they going to be doing? The audience, who are they doing this for? And then the situation. The situation is going to be your problem that they're going to be solving. Finally, you're going to have your product here at the end. This is going to be their authentic product. This is going to be the thing that they produce at the end that you are going to assess using the IB rubric. This is an example of the IB rubric we'll be using with this first in particular grasp. I've chosen criterion C to evaluate our scholars on this. They present collected and transformed data, they interpret data, they discuss validity of their predictions, and they describe improvements and extensions to the method. This rubric can look a little bit overwhelming, but as you can see, it's based on achievement level over here, and then it gives you what the student did in that particular piece. So as you go through, start with 0 and move your way down and see where the scholar gets to in the project. So this is how we use this. So instead of skipping ahead down to 7, 8, I always start with 0 and move down until I find something that the scholar hasn't produced in their product. Okay, so the last thing that you're going to see in our unit is you're going to see your learning objectives set with the day and the assessments. This is just an outline for you. If you need some scope or of how you think that this should be sequenced or what teaks you should teach on what day, this is a good layout for that. However, since this is a unit that we're going to be spiraling in, please use your professional ability to make decisions based on that. Something that I'm going to personally be doing and something we'll talk about on Collaboration Day is we're going to be wrapping in some of these teaks into the science fair. So how you sequence these is up to you before you move on to Unit 2, but please remember that these teaks are building a foundation for scholars for all of their units in science. So this is a particularly important unit. That is the end of my preview for Unit 1. Please don't hesitate to contact me if you have any questions about the way the units are laid out. I know it can be a little bit overwhelming, so if you need some context on what some of the other pieces are within that, please feel free to email me or call me or to come visit my classroom at any time. I can't wait to work with you all this year. Thank you.